Last video, woohoo! Okay. Sorry, I only have construction paper because I don't know, my life's weird, I guess. And I forgot to print off the notes again, sorry. We went over definitions of this key features in class. So I'm just gonna start with examples. If you have the notes, I'm gonna go over the examples in the notes, so it'll help you. So let's do f of x equals negative x cubed plus 2x. Negative x cubed plus 2x. And the first thing we need to do is graph this. So I'm going to pull out my calculator. It's a good thing I have a calculator for this. Okay, so negative x cubed plus 2x. And we're just going to graph that. We can go to our table here. So, and this just needs to be a brief graph. So negative 2, that's 4. Negative 1 is negative 1. 0, 0, 1, 1. And then 2 is negative 4. So that's about right there. So this is going to go up, down, and like that. Okay? And then it asks us to find the domain and range. So the domain, that is your x values. And this is left to right. Okay, so if we look at this, this is going to go forever in that direction. So that's going to be negative infinity. It's also going to go forever in this direction. So that's going to be to positive infinity. Okay, range. That's the y values. And that's down to up, or bottom to top, down to up. Sounds like it's not correct grammar, but that's fine. So it goes down forever, so that's going to be negative infinity. It also goes up forever, so that's going to be positive infinity. Okay. Intercepts. This is where we need our calculators. So intercepts, we have x-intercepts. That is where it crosses the x-axis. And let's use a different color for this. So this is going to be second, in your calculator, trace 0. Second trace 0. So if we pull out our calculator here, we're going to go second trace and then 0. And notice how I have that little spider thing that's blinking there. It says left bound. This needs to be left of that axis right there. So I just need to move it above there. Push enter. Need to move it below there. Push enter. It says guess. Push enter one more time. And you get negative 1.40. So that's one of my zeros. And I'm going to label that. So this right here is negative 1.4. Okay, let's find another one. So second trace, 0. So it's going to be below there. So enter. And then right bound has to go above that. Enter. Enter again. And that is 0, 0. So that middle point right there is just 0. I'm only labeling my x's just because I know that the y is 0 on the x-axis. And then again, second trace, 0. Left bound is up top. Right bound is on the bottom. Enter again. And that's 1.40. So this is 1.4. Okay? And then for the y-intercept, we can do that in the calculator also. That's going to be second trace value, and then you put 0 into there. So here's second trace value, 0. And it just gives you that it is 0, 0. Okay. Now for relative max, relative min, so that's what D is, relative max and mins. Or whatever, max and mins, yeah. So this right here, this is a minimum because it's smaller than all of the points around it. This right here is a maximum because it's bigger than all of the points around it. Okay, so we have a minimum and we have a maximum. In the calculator, so let's find the minimum first. This is going to be second trace min. You use second trace a lot. So second trace minimum has to be to the left of that. Then it has to be to the right of that. Guess. And so that's -1 or -0.8, -1. And let's just label that. So -0.8, -1. Do the same thing, find the maximum. So that's second trace max. Go second trace max. Left bound, right bound. And that's going to be 0.81. And let's label it up there. Okay. Increasing and decreasing. Let me grab a highlighter real quick. Okay, so increasing is when you are walking uphill. Decreasing is when you're walking downhill. So if I'm going along this graph right here, if I could walk along this would be downhill, 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 and then right here is where I would start going uphill, right there. You can barely see that highlighter. I'm sure glad I grabbed that. Okay, so for this is increasing, but it's only increasing from this point right there. And this is always x values. You always just work with the x values. So that x value is -0.8. That x value is 0.8. So it is increasing from -0.8 to 0.8. Which means that it is decreasing from here to here. So -infinity to -0.8. So you have to put this just means and, from from 0.8, sorry, to infinity. Cool. Now f, sorry, I'm gonna have to be moving this up and down because you can't see that graph, but positive and negative. Positive is above the x-axis, negative is below. So this graph is positive from -infinity to -1.4, and then from 0 to 1.4. So this is above the x-axis from -infinity to -1.4, and also from 0 to 1.4. It is below the x-axis from -1.4 to 0, and from 1.4 to infinity. Okay, end behavior. Now end behavior, this is where I think we get a little confused. So you always have to have, as x goes to -infinity, f of x goes to some number, and as x goes to positive infinity, f of x goes to some number. This is the left side. This is the right. These are y values. So if I look at the left side, so if I look at this right here, that is going up and up and up forever. So this is going towards infinity. If I look at the right side, so this right here, that's going down forever. So that's going towards -infinity. Okay, this part never changes. This is what changes. Then this last part, symmetry, A, B, C, D, E, F, G, H, symmetry. So even means that we could flip over the x-axis. So if we look at this graph, I'll just use the calculator. If I was to fold this, it would not fold right on top of each other, so that doesn't work. So this, no, it is not even. Odd means we could flip it upside down and it would look the same. So if I flip this graph upside down, what happened? If I flip it upside down, that looks the exact same. So this is odd. Okay. Let's do these other two examples. If that was enough and that helped you, awesome. If not, stick with me. We're going to keep shredding. So if we have f of x equals the square root of 4 minus x plus 2. Let's graph that. And we're doing the same exact things that we were doing, just doing. So 4 minus x, close that, plus 2. And you get that graph right there. So I can look at this and I know that, so error. That means that this point right here, 4, 2, is really the starting point of this. So when I graph this, 4, 2, that's about right there. This is just going to take off that way. Okay. Now, domain and range, let's label this point. So this will be 4, 2. Now, my domain here, that's x values. So that's going to be negative infinity to 4. And it's a bracket at 4 because it is included, because there is a point. Because there is a point. Okay, range, bottom to top. So the smallest value this ever is 2, and then it goes up to infinity. Okay, intercepts. There is no x-intercepts. This never crosses the x-axis. For the y-intercept, I'm just going to use the calculator. So you go second trace, value, 0, and it's 0, 4. So my y-intercept is 0, 4. And we can label that. So that's 0, 4. It never hurts to label things. Whatever you find, I would label it. Okay. D is relative max and mins. There's no maximum, no mins on these. Okay, never put infinity as a max. Okay, never put infinity as a max. It is not a maximum. Infinity is a special number, so that's why you don't deal with that as like a max or min. Okay. Increasing and decreasing. So this function is never increasing, so there is no increasing intervals. It is always decreasing though, so it is decreasing from negative infinity to 4. Positive and negative. So this is always positive, so this is positive from negative infinity to 4, and it's never negative. It's never below the x-axis. Okay, and behavior. So as x goes to negative infinity, f of x goes to some number. And as x goes to positive infinity, f of x goes to some number. This is the left side. So that's going to go up forever, so that's going towards infinity. Right side, that's just stopping right there at 2. Okay, symmetry. We can't flip it over the x-axis. We can't rotate it and look the same, so there is just no symmetry. Okay, let's do this last one. We have a different color of construction paper. You'd think I teach elementary school. So this one, f of x equals 2x minus 5 over x minus 3. Now, in the newer calculators, you can do alpha y equals, and enter, and it will bring up a fraction for you. So try it in yours. I don't think this one works. Yeah, this one doesn't do it. So in my calculator, if you have an old one like this, you have to put the entire top in parentheses. So 2x minus 5 divided by the whole bottom in parentheses also. Okay, and this graph looks kind of weird. This is really just going up and up and up forever. That line right there, that is really just an asymptote. And if you have a newer calculator, it won't pop up with that line. Okay, but that line is at 1, 2, 3. It's right there at 3, so that means we have an asymptote at 3. We can also look at the y, and it looks like there's an asymptote right there at 2. So when we graph this, I know I have an asymptote at 3, so let's draw an asymptote at 1, 2, 3. It's about right there. I'll just draw a dotted line. And we also have one at 2, so let's draw that right there. And then that makes graphing this easy. So this just goes like that, and this goes like that. Okay, we can label this. This is 3, and this is 2. Now, domain and range. So domain, that's going to be negative infinity to 3, and then 3 to infinity. Range, that's going to be negative infinity to 2, because there's no points on asymptotes, and then 2 to infinity. X and Y intercepts, we can use the calculator for this. So second trace, 0, right there, move it to the right, right there, enter again, and that's 2.50. And let's just label that. So this is about 2.5, or it is 2.5, it's not about 2.5. And then y-intercept, so second trace value and plug in 0, and you get 0, 1.666, comma 1.66 repeating. Okay, so this point right here is 0, 1.6. Okay, max and mins. There's no max or mins on this. Increasing and decreasing. So this is never increasing, we're just going down forever, so there's no increasing. And this is decreasing from negative infinity to 3, and then from 3 to infinity. Positive and negative. So this is positive from negative infinity to 2.5, and then from 3 to infinity. And it is negative from 2.5 to 3. End behavior. So as x goes to negative infinity, f of x goes to somewhere. And as x goes to positive infinity, f of x goes somewhere. This is the left. This is the right. So this left side right here, that's approaching this axis. So it's not going up forever like our last ones was. This is just approaching the axis. So this is really just going towards 2. The right side here is same thing, approaching that axis. So that's just going towards 2. And then there is no symmetry here. Okay, I hope this helped you guys. I'm really sorry I've just been scattered and stuff, but you guys are all awesome. I am super blessed to be your teacher, and I just hope you're having a fantastic weekend, and I hope we all ace this test. Okay, awesome. Bye.